Being fascinated by night sky is undoubtedly one of the most common feelings all human beings share. Assigning meaning to the glowing tiny dots in the night sky has been a struggle for human beings ever since we began scribbling on caves. Fortunately, modern astronomy has advanced greatly and let us explore and understand to a great extent most of the objects that we can see with our naked eye. Unlike older times, you can learn about the nature of almost every celestial object that you see in the night sky very easily. This video aims at explaining a region of sky that almost all of you might be familiar with, the Orion Nebula. The name may not ring a bell, but you have surely seen it. Do you recognize this constellation? Yes, it is the Orion Belt. The Orion Belt is one of the most recognizable constellations in the night sky. But a lot more is hidden in this region of space than our naked eyes can meet. If you have a good low-light camera and you point it at the Orion Belt, you will be surprised. This is how the Orion Belt looks like through a Sony Alpha 6300. This colored region of space is known as the Orion Nebula. Nebula refers to a region of space filled with dust, light gases like hydrogen and helium, and other ionized gases. These gases usually clump together to form denser regions which attract more mass and eventually give birth to stars. So a nebula is like a star factory. The Hubble Space Telescope took this image in 2006, and it is the sharpest image ever taken of the Orion Nebula. We use this image to explain its basic features. Situated at 1500 light-years away from us, the Orion Nebula occupies a region in the night sky that's almost twice the diameter of the full moon. Orion is a diffuse nebula, which means that it does not have a sharp boundary that could be used to define its size. The nebular gas cloud spreads out with a decreasing density as we move away from the center. For perspective, the region of space captured in this image is around 124 light-years across. In comparison, the distance from Sun to Pluto is just 5 light-hours, while from Sun to Earth, only 8 light-minutes. Orion Nebula is the brightest nebula that can be viewed here from the Earth. The source of its brightness are the stars that are present inside it. However, the colors that we see depend on the gases that are present inside the nebula. The reddish tint to the nebula is given by the abundance of hydrogen gas. Hydrogen is excited by the radiation emitted from nearby stars in the nebula. The de-excitation energy corresponds to the red end of the spectrum, and therefore reddish light is emitted. Since hydrogen is the most abundant gas in the Orion Nebula, reddish tint is dominant in the image. The blue color, on the other hand, is due to scattering. Some visible light is scattered by nebular gases, and since blue is scattered the most, we see a bluish tint. Talking of greenish regions, green hue in the image puzzled scientists for a long time because green color is neither emitted nor scattered by any gas or element we know here on the Earth. It was even thought that green light in the nebula is emitted by an exotic element called nebulium. It was explained only later that green wavelengths are emitted by a rare transition of electrons in doubly positive oxygen ions. Such transitions are very difficult to produce here on the Earth. Intuitively, you might think of a nebula as a very big gas cloud, like the clouds that we see in our sky, except that nebular cloud is colorful, but it's really not so. Although denser than free space, the Orion Nebula is still a stronger vacuum than most of the laboratories here on Earth can create. In fact, the nebular cloud of the size of Earth will weigh just a few kilograms. It's because of this strong vacuum collision-free environment that green light emitting transitions in the oxygen ions can occur easily. The Orion Nebula contains hundreds of stars. There are around 3,000 stars of various sizes in this image. Rigel is the 7th brightest star in the night sky and the brightest in the Orion constellation. Estimated to be around 200,000 times luminous than our Sun, Rigel is a blue-white supergiant that has exhausted its core of hydrogen and swollen out to about 100 times the Sun's radius. The bright central region is the home of the 4 heftiest stars in the nebula. The stars are called the trapezium because they are arranged in a trapezoid pattern. It was only discovered by the Hubble Space Telescope that there are 2 binary star systems in the trapezoid, thus making the actual star count at the center from 4 to 6, but it's called the trapezium anyway. Each one of these stars is 15 to 30 times massive than our own star's Sun, and are at an average distance of 1.5 light-years from each other. Just next to the trapezium are stars still young enough to have disks of material encircling them. These disks of gas and space dust usually clump together to form planets. Now stars like these appear to have similar disks, but it's actually a different phenomenon altogether. These stars are firing off rapid releases of super hot, super fast gases, which is typical of stars that are in their early age. Also called sneezes owing to their shape, such releases are a result of magnetic field around the forming star and can contain as much mass as our own home planet Earth. Soon these stars will stop sneezing and mature to become like our Sun. Not all regions of accumulated dust and gases turn successfully into stars though. These faint stars at the bottom of the image are a tale of such failed attempts. Also called brown dwarfs, these cool objects are too small to be ordinary stars because they cannot sustain nuclear fusion in their cores the way our Sun does.